A 2.5 kilogram block is initially at rest on a horizontal surface. A horizontal force F of magnitude 6 newtons and a vertical force P are then applied to the box. We have two coefficients of friction between block and surface, and we need to find a magnitude of the frictional force acting on the block if magnitude of P is 8 newtons and 12 newtons. And in addition, we need to find acceleration of the block A. And we start with the analysis of the problem. And to facilitate this analysis, we introduce first concept of maximum force of static friction, which is equal coefficient of static friction times normal force on the object. Scenario 1, which is possible, is the following. So we have a block on the surface. Among forces in vertical direction, we select only normal force because it participates in Fs max. Then we have a horizontal force, and in this scenario, this force is smaller than Fs max. Here appears force of static friction, which balance the force F, so they have the same magnitude, and for this reason, in horizontal direction, net force is equal to 0, and acceleration is 0. So, if scenario 1 is realized, force of friction equal external force F, and acceleration equal 0. And now we consider the second scenario of motion. Again, we have the same block on the surface. External force F now is greater than Fs max. In this case, object starts to move in direction of force with some acceleration A, and appears the force of kinetic friction, which points in opposite direction. Magnitude of this force is given by this equation, where Fn is normal force, mu k is a coefficient of kinetic friction, and to consider the motion, we will introduce x-axis in horizontal direction, and we'll use the second Newton's law for x components of forces and acceleration. Here, this equation can be considered in this form. F is positive x component of external force. Fk is negative horizontal component of force of kinetic friction, and A is x component of acceleration. And from here we can find acceleration, and this solves the problem for scenario 2. Now we continue with calculating maximum force of static friction. So we have given numbers. We have block on the surface. We select a vertical axis y normal to the block and to the surface, and we take into account the forces, vertical forces on the block. First we have external force P, we have gravitational force Fg, which magnitude is given by this equation, and we have a normal force which participate in our calculations. Then we use the second Newton's law for this axis, for axis y, because our object doesn't move in this direction. We have on the right hand side, we have 0. Writing down all components, we have here Fn positive, P positive, and negative Mg. The sum is equal 0. And from here we can find a normal force. Then we use equation for Fs max, and as a final result we have this equation for this force. Now we consider two cases. Case A, where P equal 8 newtons. So we plug in all numbers here and get the magnitude of Fs max for case A. We repeat calculations for case B, and in case B we have the answer 5.0 Newton for that force. Now we are prepared to solve the problem completely. Now we will make the last step in problem solution. In case A, we calculated the maximum force of static friction to be equal 6.6 newtons, and this is greater than external force. So it corresponds to scenario 1, and for scenario 1 we have the force of static friction equal external force, and finally it is equal 6.0 newtons. Acceleration for scenario 1 is equal 0. For case 2, maximum force of static friction is 5 newtons. It is smaller than external force. And we have scenario 2. According to this scenario, the frictional force is the force of kinetic friction. It is given by this equation. Normal force we calculated previously is given by this equation. And finally, for kinetic friction, we have this equation. We know all numbers for case B, and we can calculate this force, and it is equal 3.1 Newton. Acceleration for this case is given by this equation, and finally it is equal 1.2 meters per second square. Now the problem is solved completely. If you like this video, you may want to click like icon, leave a comment, and subscribe for the channel.